Hello guys, so we're trying to build a 3S battery using these lithium-ion 18650s, but first we need to assemble them some way, assemble them together. I figured I'm gonna use hot glue to do so, since I don't have any holders. These are intended to be, these are around 13,000 milliamp hours at 3.7 volts, of course. So these are intended to be a battery pack for a Leica GPS unit. It's a GS10. This GPS unit has two compartments for batteries. You may want to check another video that I did about this, but it also has a port which uses a LEMO connector. I don't want to show this box, especially that this is a French fucking company. So screw that. There is a battery. If you look up this number, or you would probably find the battery that it's inserted is in these slots over here and connect to the pins that come out of here. And that basically will give you the power unit through these connectors. There is one P1 that has 5 pins, and this one has 4 pins, and it's giving you the voltage around here. Like P1 is 14.4 volts, P2 is 24 volts. Probably this one is used for some other unit or the same, because it has different ports on it. And the ports for charging is this one with 3 pins. P3, you can see here it says 24 volt inputs, about 6.5 amps. The idea is to use a BMS for balancing and charging. I suppose this has charging functionality as well, I don't know, but it don't matter. We're using this boost, or actually buck converter, this buck converter right here, to bring down the voltage to around 12.6 that the 3S configuration will need for the maximum charging voltage. And then we're taking voltage out of the back terminals here on the BMS, right? And then we're feeding it to this other circuit, which is a booster, to give us around 14.4 volts all the time for the unit to function. We've already actually tested it with the unit and it powers up. So there are the power pins or outputs, plus and minus, and there's this one W something, I don't know what that is, TX and RX, I assume for some communication stuff, because if you can see right here, there's a microchip processor that is I'm not sure if you can see that. Yeah, well, it's not very visible, but it's a PIC 18F8622 microprocessor. I assume that's getting that communicates with the GPS unit somehow. This is actually not made by Leica, but actually made by some other company called Torax in US. I've looked it up. Yeah, so they assemble and design these batteries for them, for Leica, for their needs. This is the main idea. So now we're just gonna assemble these. I was hoping to get a spot welder, but I can't find anyone that sells that in here in Morocco. Okay guys, we're reverting to this tiny gun. This one is kind of somehow the glue leaked from it all the way over here. I don't know how that happened, but yeah, this tiny kind of served me well so far. It's way better than this big one, which is supposed to be a better option, better glue gun initiative. Okay. Need something flat to make this as good as possible. Let's use this one. Just grab a set. I want this to be visible, but it don't matter. Okay, let's see. I hope you can see that, but okay, I'm gonna get close to the camera with the phone camera. Okay, it seems to work pretty fine. Cells, I think, are aligned more or less. It doesn't matter that much. It's not very critical. I need to do the other side in order to have a stronger bond. Oh God. Okay, so we're gonna do the same for the other packs, and later on we'll need to solder these, either using a spot welder that I'm gonna build, or probably soldering them out, although I don't like that idea. It could really damage the cells. A lot of people on YouTube and don't recommend that, but what are you gonna do? Okay, so we finished joining together all the cells, yeah, and as you can see, we've also added some Kapton type for a little bit of protection and heat protection as well. And also because we have some cells here that have their package not like a bit damaged, like you can see on this one. It's gonna be a big back, we hope so. And yeah, I think I'll just join it using hot glue from the sides and see if that will work. Okay, here it is. It's pretty assembled. I used some hot glue on the sides over here and a little bit like in between the cells, just here and here, and also here and here. Well, it's holding pretty well. We might end up adding another layer of Scotch tape. So I was waiting to find and get a spot welder, but it seems like it's far away, so I'm gonna do it this way with soldering, and hopefully we're not going to damage any cells. So I've soldered these points, as you can see here, first, and then added this piece of copper. I'm intending to double this on each side, just like that. Now we're gonna test it and charge it using the RIMAX charger right over there. Yep, there it is. And then we're gonna add some circuitry for charging, as well as a BMS. I have this generic one. I'm not sure how well it would be. Plus a buck converter and a boost converter. Okay, here we are, guys. So we finished building this 3S pack. Yep, as you can see, I have 3S here. We've used like 2 wires to ensure that the current flow is okay. I'm not overheating anything. We've connected the pack to the BMS charger. There are the balance leads, and these are the main ones, the main power leads. It's the most negative over there, and this is the most positive. We're going to use LiPo because normally there is the option for lithium, but I mean, I should go to the settings to change that, to change the LiPo into lithium. So we're gonna put the currents to about 3 amps, 3S, yes, hold. It's still, I mean, yes, it detects 3 series. I gotta do it again, and then confirm. And there you go, it started at 10.9. That's what I measured earlier with the multimeter. It's gonna go up to about 12.6. After that, we're going to discharge the whole pack and see the capacity. Okay guys, so here we are. The battery has just finished charging. The reading in here was about 13,200 milliamp hours. Now we are on the discharging cycle. So discharging, so this is what will give us a more accurate reading We finally attached the BMS, as you can see right there, hopefully in focus, and it's wrapped all in kept on tape. Then we've got the connections made. So what I've done here is I've put a wooden plate here. This is a very thin wood, and attached the batteries, the cells that is, and the BMS. Everything is connected together. And now here we have the step down PCB board. And then next to it we have like standing up the booster PCB board, and it's held by some hot glue. I'm not sure if that'll work because I'm attaching it to the heatsink. The heatsink might get hot, so I'm gonna need to figure out some other way to properly mount this. I would have laid it down, but I don't have enough space for the connectors that I need to use here. So I need some space for the connectors. There are two of these, this one and this one, and also for this switch. I'm thinking to add this switch for some safety measure, like when I'm charging, I don't want this to be on, and when I have this on for power, I don't want to charge. So this is pretty much what I've done here. Is I've added some diodes. These are some big ass diodes. Each one is 3 amps. There are two. Assuming the battery will probably ask for the maximum current of this PCB board, which is 5 amps. So I put those in parallel. Hopefully, I'm not sure if that's correct or not. To me it seems correct, but I'm not sure if there is a better way of doing it. I mean, the current will be split across these two. If I put only one, it might be the batteries are pulling too much current for the diode and it will burn, then this will be disconnected, so I don't want that. And then this also, these are the batteries or the output of the BMS, and that goes also to the input of this booster board. This booster board then will boost the voltage up to 14.4, which is the voltage that the machine or the GPS unit GS10 will operate at. And that's pretty much it. I've got some other wooden pieces that I've made. This is like the top piece. I'm gonna add this right here, and I have a couple more like this right here for the sides. There's that one, and this one should be for the other side. The reason I forgot to mention the reason that I added the diodes for here is that when you connect the battery, kind of like the current goes to the PCB board backwards. I don't know how or why, but probably this PCB board is some piece of junk, not designed very well. I put those and it solves the issue. So here is how it's looking. It looks ugly, I know, but this is what I could do in the meantime and quickly. So I've put some 4 panels. I put the base one is this one that has the switch and the connectors, as well as these zip ties that hold the battery to this plate with the help of some hot glue, as you might see right there. There you go. And then I've zip tied the other panels to each other, just like that. So here you could just see the batteries, but on the other side you can see the connectors and also the circuits that we're using. There is the switch. There's a lot of hot glue going on in here. Behind that circuit is the other circuit for charging, which this connector connects to, and then this one is the output, and then you can turn that on with this switch right here. Now it's turned on. Oh, wait a second. Doesn't want to go off. I'm not sure why. It's probably a bit of hot glue that got leaked in here. I hope not. I hope it's just a temporary thing, but I'll check that out. Anyways, when this is turned on, you can use the battery and power on the GS10 unit. And this one is when you plug in, you charge directly with no switch or anything, so it's like that. And that's pretty much it. I'm still going to cover this and probably cover the whole thing with some kind of tape or something like that.